Hello, welcome to your lesson on the midpoint and distance formulas. Here we have an image of a famous mathematician and philosopher named René Descartes. He is responsible for the Cartesian coordinate plane, basically the grid we are used to graphing on, the xy plane. In this lesson we'll look at not only the 2D plane but also the 3D plane. René Descartes, as a philosopher, is very famous for his statement, "I think, therefore I am." That is a very secular statement and a great piece of philosophy. Okay, let's begin with the midpoint. How do you find the midpoint between 2 points? Let's say you had the point 2, 3 and the point 9, 8. How could you find the middle of that? So, in other words, if we had this on a Cartesian plane and we connected those, where would the middle be between those two along this segment? Well, the approach to this can be done like this. We can first make a right triangle out of it, and we knew that this was an x value of 2 and an x value of 9. So the distance between those 2 points there along the x-axis is 7, and the midpoint should be halfway between those. Point will be halfway between those, and if you take 7 and divide it by 2, we get 3.5. That means 3.5 away from 2 will be the midpoint, and 3.5 back, or 9 minus 3.5 will give you the midpoint. And that happens to be the point 5.5. Because when you add 3.5 to 2, you get to 5.5. Likewise, when you go from 9, you get to the same place. That's the middle of the x values. How about the middle of in the triangle here, looking at the side connecting the y values, 3 and 8? What's the middle there? Well, that distance is a distance of 5, and half of 5 is 2.5. So if you go 2.5 down from 8 or 2.5 up from 3, you also get to a similar point. In this case, this point happens to be 5.5 as well. That is purely coincidental because of the coordinates we had. These two values are more typically different. Alright, the main thing is that we know it's a halfway point on the y-axis and a halfway point on the x-axis. So, if 5.5 is right in the middle, 5.5 is right in the middle of 2 and 9, then what do we call that? What do we call a middle something in mathematics? Well, we typically call that an average or a mean. So to find the middle between 2 and 9, we can find the average, and that average leads us to this point. So how can we find an average between 2 and 9? To find the average, we can just add the two values and divide by 2. That's how we find an average. 2 plus 9 divided by 2, 5.5. And that happens to be the middle point there. And likewise on the y-axis, we could have done the same. 8 plus 3 divided by 2, that's 11 divided by 2, 5.5 also. So the midpoint is just an average of the x values and the y values. And that's where the midpoint formula comes from. In two-dimensional space, the midpoint M of the line segment joining points A and B, given like this, is this. So this is the midpoint. This is a coordinate location here. So we take the average of the x values and the average of the y values. And then that's the midpoint. It's the average point. Okay, so how do we find the distance between 2 points? So let's say we have the same 2 points, and we want to find the distance between those two. The process here is to begin by making a right triangle and using the Pythagorean theorem. So again, we're going from looking at a diagonal in a coordinate plane, but just making a triangle out of it. So if that point was 2, 3, and that one was 9, 8, we know this distance is x value of 9 minus x value of 2, which is 9 minus 2, 7. And this distance here is y value of 8 minus y value of 3, which is a distance of 5. So to find the distance, we can just do a Pythagorean theorem on this right triangle. So we have a coordinate plane. We can do 7 squared plus 5 squared and equals d squared. Add those up. 74, take the square root of both sides, and we have 8.6. So the distance is 8.6. So when you use the distance formula, always remember it comes from the Pythagorean theorem. So let's look at it as a general form. So we have a point, another point. To find this distance, we do the x value of the second point minus the x value of the first point. Over here, we do the y value of this point minus the y value of this point. That's how you find the distance. along those segments, and then to find this distance between the 2 points, we run a Pythagorean theorem, and we take the square root on both sides. So this is a distance formula. You may be familiar with it, but make sure you know it's very important to remember that it comes from the Pythagorean theorem. So we see Pythagorean theorem here, and there it is. Okay, so the distance formula in 2D space between 2 points is this. Again, that's the Pythagorean theorem. Alright, now that we've recapped midpoint and distance formulas, let's look at them in 3D space. So here are some 3D solids, and you can see they can unfold into what is called a net diagram, which is a 2D representation of the surface. So the question is, just to get your mind thinking in 3D, which of these could be folded, or which of these nets could be folded to make a cube? Okay, let's talk more about three-dimensional space. Let's say we have a three-dimensional space. We can use it, we can represent it using a triple axis. So here's x-axis, y-axis, and the z-axis. Typically they're shown in this orientation, with the z-axis being the one that goes up and down, and the y-axis being the one that goes back and forth, the one that would, from my paper, pop out at us in 3D. Okay, so positive values of y go into the page in the reverse, and negative y values here, and then we have positive z, negative z going down. Okay, points in space in 3D space can be graphed on what's called an XYZ coordinate system. Alright, so in 3D space, the location of A is determined by an ordered triple. Before, when we had points in 2D space, we called it an ordered pair. Now it's called an ordered triple of coordinates XYZ, where each coordinate determines the location along the XY and Z axis respectively. So you can see this point is floating here in 3D space. Here's its X location when you go along the X axis. Here's its Y location, and then going up is its Z location. So X, Y, and Z. Okay, so let's look at this one here. We have this point here that went out here. Okay, that point is only along the x-axis. It's right on the axis, so it didn't move out in a y direction. It did not go up in a z direction. So that one has coordinates 4, 0, 0, because it only went along the x-axis. How about this one right here? This one only followed the y-axis. It did not go along the x-axis, so it stayed 0 from the along the x-axis. It went 4 or 5 here, and it did not go up at all, so it is just 0, 5, 0. And this last one, what's the coordinates of this one? Well, that last one is 0, 0, 2. It did not move along the x-axis, did not move along the y, it just went straight up. So 0 along both of those, and 2 on the z-axis. Okay, with that in mind, let's start talking about 3D coordinates. You can see this cube has been drawn in 3D space, and each vertex has a specific location. For example, this location here, it moved along, it did not move along the x-axis, so it has a coordinate of 0. To get to that point, we move along the y-axis, 1, and then we go up along the z-axis, 1. Pause if you need to and consider some of the other vertices to make sure you know how it works. Okay, so my question to you is, in a moment, what is the location of M, which is the midpoint along SR? We'll figure that out in just a second. For now, so let's take a look. M was 30, 40, 200. Why? Because it's the midpoint along SR, and SR connects these two corners. Okay, so to get there, to get to M here, we had to go halfway here, and halfway here, and then up to here. So let's take a look at what that means. Halfway here is halfway along the x-axis, 30. Here is halfway along the y-axis, which has maximum 40 here, but we went 40. Sorry, 80 here, so we went 40. And then from there we went up along the z-axis to get to here, and that is half of the 400, which is 200. So this that midpoint is not only a midpoint of this segment, it's kind of the midpoint, well, it's a midpoint of this segment in 3D space, right? So between S and R, that is the average of all three X, Y, and Z. So in 3D space, when we have points A, B, like this, given with x, y, z coordinates, the midpoint then is a coordinate that is the average of your x and y and z values. So it's the same as the midpoint formula before, but now across 3 coordinate axes. Okay, so state the coordinate of C and D, and then find the midpoint of CD. Let's check our work here. The coordinates of C is 600, and D is 074. And then the midpoint, using this new midpoint formula in 3D space, it's segment connecting those two, and the midpoint, you set it up with the x average, y average, and z average. And that midpoint ends up being this coordinate here. And I have that point right there. Okay, check that carefully. It's a pretty simple formula. Once you get it, make sure you know how to use it. Okay, so now the distance formula works the same way. In 3D space, we had our 2D distance formula. In 3D space, the formula is exactly the same. It's like 3D Pythagorean theorem. So we have the x part, the y part, the z part, the root of that. It's just the same thing as this one with the extra coordinate bit added there. Okay, with that, you're ready for this problem. And this one, first question is, if each side here of this cube has a length of 4 units, list the coordinates of each vertex. Okay, let's check all your coordinates here. Again, pause if you need to, just to make sure you really understand how that works. Alright, let's pick 1 as an example. Let's go to E. E is right here. To get to point E, we had to travel along the x-axis, 4 units. We did not move along the y-axis, which would be this direction, but we did go 4 up along the z-axis. So it's 4, 4, 0 on the y, and then 4 on the x, on the z-axis here. All right. Next question. Find the coordinates of each point. Point H, and I'll tell you that point H is on this surface here, this surface AEFB. Okay, it's on that face of this cube, and it's in the center of that face. Okay, those coordinates of H is 4, 2, 2, because you go 4 on the x-axis, 2 on the y, you only go halfway, and 2 on the z, because you only go halfway there. Now find the coordinates of a point right in the center of this cube. Well, that point will be 2, 2, 2, because you'll go 2, 2, and 2, and then you'll be sitting right in the middle there. Okay, so we're ready to try another one. The question now is, find the length of each segment OB and segment OF. Okay, this one might be a little tougher. Let's take a look at how it works. To find segment OB, we can connect O and B. Notice that O and B are connected along the bottom of the box. They are not really in 3D space. It's just a segment on a flat surface. So in that case, it's just a simple Pythagorean theorem using this triangle on the bottom here. So here's that triangle redrawn. It's triangle OAB. Notice it's drawn here. So to find OB, we can just use Pythagorean theorem like this. And when we solve that, we have OB squared equals 4 squared plus 4 squared, and that is root of 32. Okay, how about OF? OF connects this point and this point. Those 2 points are connected in 3D space, but we still have a right triangle here. That right triangle, try to imagine it, it's not flat on the surface of a face like the bottom triangle was. It is a right triangle that's standing up inside the cube. To find that right triangle, or to find OF, we need to know OB and FB. Well, we already know OB, we found it here. So to find that standing triangle, which is here, it's OF squared equals OB squared plus BF squared. And OB squared was the combination of these two, which we had here. So notice that OB became this. And now this, we can take the root of all that. So that's where that triple distance formula comes from, the distance formula like with the 3 parts in it. And that, if you solve it, then is this. There's the OB part, there's the new part there, the BF, and then we can find the root of that. It's root of 48. Great problem. Okay, so now try this one. Okay, using the 2 formulas we just learned about, the 3D distance formula and the 3D midpoint formula, we can find these 2. Now make sure you go back and try a practice assignment. It's a short one, but you'll practice these same skills to make sure you got them done just right. Great work.